Okay, so let's say that the entire application is complete. A user has downloaded it and want to use our framework for his own backend application. So let's say that he has a endpoint which is /users/login, and he simply wants to send username and password and see if it's the correct one. So his front end will communicate with the back end and log in. This is going to use a post request. So he will do two things using our framework. He will code this in C, and he will create one file to handle this. The first thing he will create is a DTO, a data transfer object. And it's not really an object, since we're talking about C, it's actually a structure. So he will do something like struct, maybe s credentials. He can name it to whatever he wishes. And inside of here, he will simply have something like char username 16, char password 16. So in this he defines how he wants the data to be sent, and then he creates a decorator with the DTO function, and he links this struct s credentials to the name, let's call it cred for credentials. Okay, so now he has linked the structure to a DTO named cred. The next step, and the last step, is to create the actual endpoint, and that will be a function. So we will create a function which will return a bool. So true is it succeeded, and false some kind of error. And let's call this login, and it will take two arguments. The first is and it will always take two arguments, all these functions. So the first is a request object or a request structure, and the second is a response structure, res. So the request structure will contain things like the endpoint name. It will contain what kind of HTTP method, like post or get and stuff like that. It will also contain possibly cookies and headers, and also the data that's being sent, and that is pre-processed. So he will put a decorator here as well. In this case it's going to be get request, so he uses this function, and he simply links the login function, this is a function name, to the actual endpoint, which is this case is users/login. And let's say the user will send I will put this in a comment. The front end will send a JSON object. So the JSON will look something like this. Always begin with those, and then we will have username, and let's say Jonas, and then password orange. So this is the original JSON object. What will happen is our front end will take this JSON object automatically and map it to this structure. And remember the name cred. So now he can define two pointers just to make it more clear. So let's call it user and pass for user and password. We will set user equal to the request object dot data dot let's see, it will be, no, not like this, it will be request and then cred, the name of our DTO, and then the username. So cred will automatically come from this that links to the structure. Then we have username, it goes here, and we do the same with the password, like so. And now we can simply do a regular string compare. So if let's say if the user is equal to Jonas and the password is equal to orange, what do we want to do in this case? Well, we will probably do something like maybe set a global login flag or something, maybe edit the user's session. So we can go into the request session and perhaps we have prepared this in some way so it knows that it should have a logged in field, and we set it to true. So this session is specific for the user and connected through the session ID, which works like any other REST API. And then we will send a response, and we'll do that by simply doing return and then JSON to send a JSON response, and then we craft the JSON response, and we use single quotes inside of here instead of regular quotes, otherwise it's standard JSON. So this will basically be something like logged in true. And if it's not the correct one, then we will simply do two things. We will change the response object's error code to, let's say, 301, and we're going to return HTTP error, and we will just send something like, we need to specify the response object, and then we will send something like unauthorized. And this is the entire thing. So the user can, the user of this framework can easily create those small C files, can reuse the DTOs for different places perhaps, can have get request, oh, by the way, this is not a get request, this is a post. But can I have all the different types of requests this way, and when the user is done with this, he doesn't need to shut everything down, recompile the web server and all its contents. The only thing it does is just run some command like make build or something like that, and then this whole file will be compiled into a dynamically linked shared library, a .so file, and that library file will then be hot loaded into the main application. So directly after make build, no need to restart anything, no loss of data or any connections. This endpoint will be active. So this works pretty much similar to all the JavaScript backends. But this is pure C, and you have all the possibilities of using C. You can use libraries and all the different code in order to make your application really cool. And you will also be able to use a lot of features from the main application inside of here. So that is what we are about to build, guys. Kinda exciting, right? Let's get started. All the code in this project will be available through repo.drbirch.com for 48 hours after release. So let's begin by logging into my server, CodePlanet, and let's create a screen. So let's see, I will use 250. I will go into my temp directory and I will call this project webdev.c. Because a lot of these similar projects have like names like Nest.js and stuff like that. So why not .c? So webdev.c, I will set this directory to my home directory. And I think I will, that's good enough for now. So now I'm going to start the Sociopath SCP client so I can code remotely directly on the server. And if you want to download this, you can go to Google, search for Sociopath SCP client. It's available to both, it says Mac here, but the original version was for Mac, but now it's possible to download for Windows as well. And it's totally free and no limits except that it's evaluation license only lasts the year out, but usually it's possible to renew without any cost. You can, however, pay for the pro version if you like, but that's not really necessary. Alright, so let's start this tool. And it looks like this. Doesn't quite fit on the screen, but you get the picture. So we go to connect and enter our host name and password and stuff like that to our Linux server. You can also connect via a authentication key. And let's go to our temp directory and open our new directory, which is a little bit off screen, I think. No, where is it? Webdev.c. So don't double click on it, just select it, right click and open in editor. Make sure that VS Code is your current editor. And I need to close my old thing, don't save. And I will move this so it fits on our screen. I hope it's big enough for you. Okay, so now we have the directory here. Let's say I can make it a little bit bigger, I think, like so. Let's say that I want to minimize this. That I right click here and create a new file, and let's call this webdev.c, and I will simply put some comment here, webdev.c, and I save this. If we now go to the sociopath, we will see right here that it's, let's see if I can zoom in a little bit. WebDevC has changed, successfully updated to server. So every time I save a file or create a directory or anything like that, it will automatically update the server. So I think this is a nice way to code, which makes it possible for me to use VS Code, which is good for bigger projects like this. Let's also create a webdev.h. I will put a comment right here, webdev.h, and I will put some include files. I usually start with, I think I can make it a little bit bigger. I hope smaller. I hope this is okay. So I want stdio, I want uni std, I want stdlib.h, string.h. I also want to have assert.h, and for all the functions for some of the functions this requires number.h, and that in turn requires that we define GNU source. Right, in addition to this, I also want stdbool.h, so I get these boolean values. And I will not include stdint because I prefer to create my data type myself. So let's see, I can remove this a little bit now. And alright, so let's start with those data types. So I'm going to move down a little bit so I have space to work. So let's see, we want to have a typedef unsigned char, which will be our int8. We want to have a typedef unsigned short int, which will be an int16, and that means 16-bit. And we'll have typedef unsigned int, which will be an int32. And finally, typedef unsigned long int, which will be an int64. And one thing I have started doing is creating a couple of, let's see how I did this. I create a couple of macros. So let's say I define $C to be char. So this is for typecasting. And then I will create, so for this number variables, I will have the last digit. So $8 will be int8 pointer. $6 will be an int16, not a pointer, because I usually use this for numbers. Well, we'll also have a $2 for 32, so int32. I will have a 4 for int64. I rarely use that, but it's good to have. And finally, I will have a $I for regular int when we need to convert in that direction. Because with those, when I use my own data types, I need to do a lot of typecasting. So let's say, for example, that I create an int16 x, and I want to call the, let's say, string length function, or maybe let's do the open function. So let's also create an int8 pointer called p, and we'll set p equal to some file path. So let's say my file.txt, and then x will be equal to the int, let's see, the 6 version of open, which will use the char version of p, and then some flags like I think it's o rd only for read only, like so. And then we can check if x is equal to, like, I'm not sure, I think it's less than 0 or less than 1 if it fails, because it should return a positive integer. Okay, it can't really do this. Maybe we should let's do it on the other direction. So if x is more than 0, then we do nothing, but else we can print some error. So this is how I use it, because it would be difficult to add all those typecasts which are necessary when we use our custom variables, variable types. Alright, so let's create some function definitions as well. At the moment we do only have our int main, which will take an int and a char double star, and that's all we have at the moment. We do, however, want to create a function that will sorry, that will return an int32, and let's call this setup server. And what does this need? I want to have an int8 pointer, so basically a string, which will be the IP address that we want to bind to. And I also want to have an int16 for the port. And let's see, do we need anything else at this point? I think everything else will be boilerplate, kind of. Alright, so let's start developing this setup server function. But first we need to include our own file, which is the webdev.c, no, h. And I also want to include birchutils.h. That's my own library with some utility functions and helper functions and stuff. You can download this on this link, https repo.drbirch.com. A lot of things on this repo is members only, but the birch utils you can download because it's used in all my new projects. Right, so let's create an int32 set up server, which will take an int8 and host and an int16 port. We will have a struct sock address in sock. We will have an, let's make it an int32s, and let's begin there. So s will be equal to the 32-bit version of the return value from socket, and we send AF inet for internet. We set sock stream for TCP, and the last we set as 0. So let's go to our terminal and just check the return value of socket in the second man page. On success, a file descriptor is returned. On error, -1 is returned. So basically we want to assert. At this point we can actually assert. And we will assert that s is bigger than 0. So if it's not, the program will fail at this point. Right, I also think I want to do some syslogging in this case. I have actually never done that in C. I need to think how to do it. Maybe there is some syslog function in the standard C library. Seems like. Alright, so open log, ident option facility. And then we have syslog, priority, format. It seems that this works similar to printf. And then we have close log. Open log opens a connection to the system logger for a program. String is pointed to by ident. It is typically set to the program name. Alright. And the option, then we have different flags. And what does this say? The use of openlog is optional. It will automatically be called by syslog if necessary, in which case ident will default to null. Okay, we don't want it to default to null, so let's open it. I need to create my own function for this, and also an alias. So let's see. By alias I mean a definition, a macro. So let's see. Maybe we can just use a macro. No, let's do this right. Alright, so we'll have a void function which will it will log something, and what do we need? We actually don't need anything more than the actual message, I think, because the rest will be the same each time. So the ident, the option we need to check. The facility is the some kind of identifier, I think, and the priority is the severity, and then we have the format strings. Yeah, so let's just do it like this. We will take a let's see. what if we were to do... No, I think we'll just make it easy for the time being. We send one int8 pointer representing the message to log. And then we can maybe combine it with some other function like sprintf or something like that. Okay. So let's make this function before we continue with this. And this will be a void function. We'll call it log, and the only thing we have is a string like this. And we need some kind of identifier for this return value of open log, I suppose. No, it contains a void actually. Interesting. Maybe it has some kind of internal state. Alright, so all we need is ident and option. What is option? Values for option. Log cons, write directly to the system console. Log and delay. Log no wait. I'm not sure we need any options, to be honest. So let's try without. And facility. What does it want for facility? Okay, it's basically what kind of log file it should end up in. Log auth priv, log daemon. We could use log daemon, but I think we will just use the syslog. Alright, so let's copy this. Let's go up so we see the syntax. Ident option facility. So we don't need much of a variable. We'll just do open log, and we will give this a string of webdev.c. We'll test by setting this flags value to 0, and then we will have the log syslog like this. Then we will do the actual syslog message. And no, that's not right. And for the syslog we need priority and then the format string and the rest. So what should we use for priority? Log alert, log critical, log error, log warning. I think we can just do log info. Perhaps we can do another function which logs errors. Maybe. Or maybe we can take this as an argument and then we create a macro for it. I think that is better. So let's call this syslog, but that will collide with this one. Let's call it syslogger. And let's remember to change this. And we'll add one parameter. I think I built it that first. And this will be the int 16 of priority. So int16 priority. So we will send the let's see what's the order. Okay, it's first the int version of priority. Then we have a format string, and then we will have the actual string. And how does this close log function work? We just do close log without any arguments. Interesting. Alright. So let's do that. Close log. And then an empty return. And now we want to create macros for the different priorities. So we'll have an log, which will be the basic log info. Okay, we're not doing that. We will just give an x here, and we will transform that into syslogger with this level and x, like so. We'll also define log warning of x. And then we'll run syslogger log warn, I think it was, with x. And finally define log r of x, which will be syslogger log r of x. And we need to line these up. Alright, that looks right. So let's temporarily, no, that one should be left. I will temporarily remove this, I think. Or maybe not, by the way. Oh yes, by the way. Because I don't want to get the errors because we don't have the include files for the socket thing yet. And I will, however, create a main with an int argc and a char argv. Should be star argv, and then this. And I will just test the log function. So basically I want to create an int8 string, which I will set to server starting up. And then I just do log str, like so. And let's return 0. And let's create a simple makefile for this so we can compile it easily. So I will do a quite standard makefile. Let's remove this. So what do we need? I want to have some flags. And let's do o2 wall and let's see, is it standard equals c to x, I think. And we might have some ld flags for the linker. And we need to compile the webdev.o with a dependency of webdev.c. And I'm quite annoyed by all this when I press enter, it selects something completely random. I did find a way to change that. Let me see if I can remember what I googled. Stop VS Code from auto completing on enter. Let's see how to stop autocomplete with enter. Let's remove this, and what is this? Accept suggestion on enter. Alright, let's try searching for enter. So in VS Code we can, it will be a little bit off screen, but if we go to the menu and go to the command palette, no, that's not right. We need to go to file and get into the settings. I think there's one file, at least on my Windows machine it's there. Maybe it's somewhere else on my Mac. Maybe I can search for it. Settings. It's on the code menu. And then I will go to settings. I will search on enter. Accept suggestions on enter. Off. Let's see. Okay, maybe that's enough. So let's try writing this webdev.c again. So webdev.c, it has some crazy substitution, but when I press enter, it won't change. Wonderful. All right, so let's run cc with our flags, and we want to take the source file and run it against -c to create the O file. When we have the O, maybe I could, let's see if this works, if I put webdev.h here as well. So if I change the H file, it still want to compile. And then we want to create the webdev server, the actual executable, which will require webdev.o. Then we'll run cc with some flags, and we want to take the source file and create our target file. And we might even have some LD flags at the end. In addition to this, I will have a clean, which will simply remove webdev and all .o files. And we also want to have an all, which will run clean first and then webdev. And then can't really remember how to do this, but I think it's phony, and we give it all and clean. It's to tell the make program that all and clean doesn't actually compile anything. It will just be some object that links to other objects. I think this is the syntax. I'm not 100% there. Perhaps we can go into the make man page and search for phony. No, what about make file? Alright, let's Google this. Phony make file. Phony. Can we give an example? Let's see if I can remove all annoying pop-ups. Foobar. Okay, I think I did it right. Dot phony and then this. Alright, sounds good. So let's see. Did I save? Think so. So let's see if I did this right. I will run make. Alright, we need the birch utils h. So where is it? I think it's one step up in the code. Or it's 2 steps up in the code. Okay, so let's continue with this. We are looking for the birch utils directory. And there we have this library and we have the H file. So let's copy this path, and this is temporarily during development. Then we will have installed the library globally on the system. So let's see. We want to go to our, where do we want to put this? I think we can put it right here. So we include the local path of birch utils, birch utils.h. And in the make file, we will temporarily link directly to the binary. Let's call this TMP for now. Or, yeah, let's do that. So TMP will be equal to this path and birch utils.o. That should work, I think. So let's see, will our code compile? I don't really remember if we did everything with it. If we do make, it doesn't find that file. Oh, it didn't update, I think. The make file did update. Maybe I didn't save the other one. So let's go back to our H, and I want this in this order. And let's just save again. Okay, that's better. So let's run make. Still complaints about the same thing. webdev.c. Okay, I included it in the other file as well. I don't want it in the C file actually. So let's do this. Run make. Alright, so let's see what we did wrong. Open log implicit declaration. Alright, let's check the includes for that. Open log, that's syslog.h. That makes sense. So in our header file we will include syslog.h. We make again. Let's see, pointer targets in assignment from char star to int8 star. Okay, line 25. this one? No, that can't be right. Okay, sometimes when we do those macros, the line numbers get a little mixed up. Oh, I'm in the wrong file. My bad, sorry. Okay, here we are. Yeah, this should be an int 8. So let's just add a $8 there, and it will be converted. This is why it's good to create those macros. And now it compiles. Let's see if we can log to the syslog. Okay, nothing happened on the screen, but that's anticipated. Let's tail our var log. Is it messages perhaps? Or just syslog? What do we have here? The names are a little bit different than I'm used to. What if we check the syslog configuration? Sysctl. Let's search for syslog in this file, in this directory. Syslog, like so. Print. Nothing. Okay, maybe it uses this new sysctl thing as the new syslogger. Why do they have to change everything? Linux were so good as it was before all this systemd and sysctl nonsense. Alright, how do we find this stuff? Let's see what we have run in systemd login, dbus, system activation. What is this? Syslog only. Dbus daemon. What is the dbus daemon? Message bus. Force the message bus to use the system log for messages, but no, that's not what I was looking for. What if we were to do an ls of and we grep for var log. ls of shows all open files and open connections and stuff. systemd something. Which part is the PID? Let's see. Okay, we don't get that first line, I guess. Looks like a little too big number to be a PID, but let's see. No. Okay, let's just do ls of head. command PID, right? So command PID, so this is the PID. That's quite the number. Alright, so if we go to that directory /proc and the PID, we should be able to check this exe file. And it points to systemd journald. Okay. If you go to etc. and we search for journal. There we go. Alright, so where does it store? Okay, maybe this is something that stores everything in memory. Or in some kind of a database format. Then we should just be able to do journal tail, I think. Okay. Server starting up. Web dev C. It works. Our syslogger works. That's good news. Alright, so now we can log things. That's always a plus. Let's remove this stuff for now. And let's continue building our setup server function. So when we have a socket, we should fill in this sock structure. So the sock syn family should be AF inet, and the sock syn port should be the hton s of the port, and we need to convert this to an integer, and the sock syn address s address will be the inet address of the string of the host. So that's the IP number basically. And when we have filled in all the structure, we need to bind this to the socket. So we do bind, and we give it the socket file descriptor. We cast the struct sock address and the reference to the sock, and the third argument, I think we just do size of sock. I don't really remember. Maybe I should double check that so it's correct. So let's see. Man to bind address len address len. Address len specifies the size in bytes of the address structure pointed to by address. Traditionally, this operation is called assigning a name to the socket. Alright, so that's good. And this returns an integer. And how is the value? I think this should be 0 if I don't remember correctly. On success, 0 is returned. Alright. So let's create some variable for the return value. we can make this an int16 n. Set n equal to the 16-bit value of this. And then we assert that n is 0, right? So that's step number 2. Step number 3 is we listen on the socket. So then we just do listen, and we give the s and how many connections should be waiting. Since this is a web server, it should be fairly high. So let's say 50 in our case. I think this is the correct syntax. Run to listen. So give the backlog. And what does it return? On success, 0 is returned, right? And by the way, I use assert every here and there, but you should never use it in production code. I just use it in my videos to make the error handling a little bit easier, because a lot of a program is basically error handling, at least when you code in a language like C. So assert that n is 0. So now we have done the socket, the bind, and the listen, which means we will just return s. What is the type of this? It's an int32. Alright, yeah, int32s. So we can return it as is, and then everything is set up. So the only thing we need to do here is let's create some pointers, int8 host and port 8, let's call it. And if argc is less than 2, so we have only one, we don't have any arguments, and then we produce the usage, and we fail with a 1. I will create this fail function later. And if argc is equal to 3, so we have one argument but not both. We basically have the port in this case. Then we will set the set port 8 equal to argv1, and let's send this thing to usage. And we'll also create an int16 for the port. So the port 8 will be that, and the actual port will be the integer value of the char variant of port 8. And since we don't have an IP address to bind to, we will simply set the host equal to the static string of 0000, which means it will bind to every interface. And in the last case, we will have at least 2 arguments. So now we can do basically the same. We set our we set port 8 equal to argv1. We set host equal to argv2, and port is equal to, that's right, we need to make this int16. Port is equal to the int16 of a to I of the char string of port 8, like so. Yeah, that's everything. We will also create an int32s, and if we get this far, we'll do s equals to setup server, and what order did we save the arguments in? So first the string, then the port. So we send the host, the host, and the port like this. And we don't need to do any error handling with s, because if we get this far without exiting the program using the assert, then we will successfully have set up the server. So let's log server. Let's see. I want to send the. Let's create a temporary buffer. We'll do an int 8 of buff. Let's make it 128 perhaps. We will 0 our buffer, 128, and we will do an sn printf. We will fill our buffer with 127 maximum bytes of data, and we want to say something like server successfully listening to, and we take the host and the port, like so. And let's break this up a little bit so we can get room for it. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, welcome back, guys. I recorded almost an hour yesterday, and my computer crashed and I lost the entire file. So I will show you and go through what I coded during that time period. I didn't get too far, and if I would miss to mention something, you will have access to the code for the upcoming 48 hours on the repo. Alright, so let's see. Syslogger, it was finished before, and the setup server we had also done. What I have added is, if we begin in the main, I created a main loop, basically this. So I have a variable which is a bool, a global variable called continuation, and when it hits true, it means the main loop should continue and accept connections. And when this is false, it will break out of this and close down the sockets and exit. And this is a very simple construction, just a while loop with one line inside of the body. And ret is just a regular int of some kind, it's an int 8. So we run this function, main loop, and we supply it with the socket file descriptor. When the main loop exits, this return value will be our exit code. And this main loop looks like this. So what we do is we accept the connection, and this accept call will be waiting until it successfully gets a connection. And what it will do is it will fill out this structure with the information, like the IP address and the port number in network byte order, same as we would use when we connect somewhere. And it will return a client socket file descriptor. So if this is more than 0, we do nothing, but else we will so if this fails, we will set this string to accept failed. We will log that as a warning. We will sleep 1 second and we will return 1. So why sleep 1 second? Well, this function main loop will go round, 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 round. It will be a loop. So if this accept function would freak out somehow, perhaps because we are run out of memory, we don't want it to loop, loop, loop without any stop. So it will wait 1 second and then go to the next round. If we, however, are able to accept the connection, then the accept call will start that connection up, and then we will fork. So, and fork will return a positive value when we're in the main application. So everything inside of here is the main application. And it's not the children process which is created by the fork. And what do we do here? Well, we want to save the host and the port from the clients, so we can have some kind of data structure with all the different information, and we can relay that to the to the backend .c files that the user has created, so it can check for IP address and stuff like that. So since it's in network byte order, I have one variable host and one port, and host is just a regular int8 pointer, and port is an 16-bit integer. So we point the host to the sock SYN address S address, which is the IP address in network byte order. We will use the toDotted function from Birch utils. And if you don't have Birch utils, or you wasn't here when I created it, you can download that always from the repo, no matter if it's gone 48 hours or not, because that is used for almost every project. It's a library where I save functions that I need to rewrite for many projects. So toDotted, it simply takes this IP address in network byte order and creates a regular string out of it, like 192.168.1.10 or something. And we need to do the same with the port, because when we have a port number and we turn it into network byte order, we use a function called age2ns. But we need to turn it back somehow. So I created a function yesterday. That's one of the things that got lost, the video, inside of Birch utils. So you can update Birch utils, or you can download the file. And this is a function. I call it ns2h, so it's backwards. It takes a regular int16 port in network byte order, and it reverses it. So basically, if we have a port number in hexadecimal, which is AABB, we want to turn it into BBAA. Okay? And how do we do that? So we divide it into two parts, 1 byte each, so 2 hexadecimal numbers per variable. And we have an A and we have a B. So first we grab the A by taking the source port and ANDing it together with this mask. And what does that mean? So if we take this and we do the mask below it, we want to grab the A's. So we select them by putting F's in this position. And we don't care about the B's at this point, so we set zeros there. When we do this AND operation, we will get those two A's and those B's will be zeros. So that's what this parenthesis is doing. But we can't have those zeros here. We need to push the A's to the right. And that is what this bitwise right shift operator is doing. And we want to shift it 8 bits. And since 2 of these hexadecimal characters represent a byte, or 8 bits, this basically means that when we push those to the right, the 2 A's will end up here. And these will be zeros. But zeros on the left side of a number like this can be reduced. So then we have the 2 A's inside of our A variable. How do we grab the B's? Because we had AA and we had BB. Well, we do basically the same, but the reverse. We take the B, let's see, no, here we are. We take the source port and we AND it with this mask. So we AND it with 2 FF, and as you know, you can fill up zeros here. So FF is selecting those, and the A's will be 0. So this is a mask because we can reduce the zeros. But the result will be 00 BB. And since the zeros can be removed, we will have the B by doing this. Okay, so now we want to add those together because we don't want to have A's and B's. We want to have the result of BBAA, right? And we achieve this by taking the B, pushing it 8 bits to the left, which means, by the way, we take the destination port and fill it with zeros first. So what we have now is this, 0000. Now we take the B's and we push it left 8 bits. So we have, if you begin with the B's, this is what we have. And pushing it 8 bits to the left will give us BB00. And in order to get the A's there, we can just plus it. Because BB00 in hex plus anything, we'll just add it here. And then we have the port. I hope I didn't run through it too fast, but try doing this yourself as an exercise, because it's very good to know these kinds of things. You have seen me do it by perhaps 5 or 6 different videos. So make sure you learn this stuff. Okay, so that's that. What else did I do? When we have this, we will zero a buffer, just a regular int8 buffer like this. I will use smprintf to put the stuff inside of it, and I will just say client connected from the host and the port, and I put it here. And I need to cast it to the right stuff. And then I use our log macro to log that. So that is basically what I did. I think we got it all. Yes. And let me check the H file as well, if I did any changes. No, I didn't change anything here. The only thing I did was I added the main loop. And the usage, by the way. Forgot about that. This is a very simple function that only takes one string. Let's see where I put it. Here. So it takes a string. To the standard error, it will print the usage and tell us that this is the name of the application executable. And it will require a port number and an optional host. And if the host is omitted, it will use this regular 0000 and listen on all the different IP addresses of the host. And then we exit the whole application by exit -1. So I can have a simple if statement like this. And I should move this up because it's similar. So if we only have one arg, we will do if we have no args, we'll do the usage. If we have one argument. No, if we have both arguments, we do this. I'm getting a little... Let's see, if args is less than 2, that's when we have 0. But it should be equal to 2, I think. In that case, we should set this to 0. And if it's equal to 3, like in this case, we will just use those two arguments. Okay, so that was a little mistake. This should be if argc equals 2. And let's check that it compiles. We get a little bit of warning because of the control that reaches the... I can show you. If we go to number 73, the control ends without us doing a return. And the reason for that is that this function is not done yet. We will continue and handle how the children thread or the children fork will do stuff. And we also want to save these host and port somewhere, perhaps in a linked list or in a tree or something. I'm gonna think a little bit about that. But yeah, that's good for one day, I think. So try to finish this application as long as I have come, and make sure it compiles without any additional warnings except the one I have. And yeah, try to do the binary bitwise operator stuff for the port numbers, because it's a good exercise. And if you like this series and if you like my channel, please like and subscribe. And I will see you real soon. Thanks for watching. Thanks for today.